off 6.1, which is different forms of linear equations. So as we said last time, there's 3 different forms, and last class, or last video, we did 2 forms. We did standard form and we did slope-intercept form. So today we have to do the third form, which is point-slope form. So let's do a quick review. Standard form is ax plus by equals c. And remember a couple things. First of all, this a value here, we want a to be greater than or equal to 0. We don't want it to be negative. And then the other thing is that a, b, and c are all integers. Or as I said last time, to be more specific, b and c are integers, a is a whole number, because we already said we want it to be positive. Okay, that's standard form. The next type we talked about was slope-intercept. This is the one that's so easy to graph. Y equals mx plus b. And what you should remember there is m is slope, and b helps you get the y-intercept, because the y-intercept is going to be equal to 0, comma b. Whatever number there is will be our y-intercept. Alright, what else? Oh, there's one other thing I wanted to mention here. Some examples of standard form are like 3x minus 2y equals 8 and 2x plus 5y equals negative 32. You'll notice in both of those examples, there's an x, there's a y, there's an x, there's a y. So this x is always there and this y is always there. Right? The numbers that you're going to put numbers in the a, b, and c, but there's going to be an x in your standard form equation, there's going to be a y in your standard form equation. It's the same with the x and the y in slope-intercept form. You're definitely going to have an x and y there. So for example, you could have something like y equals 2/3 x minus 7, or you could have y equals negative 3x plus 2. You'll see that there's an x and an x and a y and a y. That's always going to be the case. The reason I'm making a point about that is because point-slope form is a little bit complicated looking. It's y take away y1 equals m, and then x take away x1, and this y here and this x here are always going to be in the equation. There'll always be a y there and there'll always be an x there. But these other 3 numbers, the y1, the m, and the x1, that's where you're going to have numbers there. Okay? So what are those? Well, you should know what the m is. We've already talked about m a whole bunch of times. M is slope. And then the y1 and the x1, that is the line goes through the point x1, comma, y1. So point-slope form, you use it when you know the slope of the line and you know one point it goes through. But you probably wouldn't use it if you know the y-intercept, because then you would use slope-intercept form. But what if you know a point other than the y-intercept? Then you use point-slope form. And usually what we do is we switch it from here into one of these 2 forms. We'll see that later. Alright, let me give you an example here. Say that you knew, so I'll put it over here, example. Say we had a line and it had a slope of 5/6 and it went through the point 2, negative 5. And we want to write down what the equation would be in point-slope form. Well, remember what I said, these highlighted y and x are always going to be there. So you're definitely going to have y, and I'm going to skip the minus y1 because this is the confusing part. Equals, okay, we can definitely get m. M's no problem. M's the slope, so that's 5/6. Bracket. X, that highlighted x always has to be there. And then again, I'm going to skip. Okay, so what we're left with is the x1 and the y1. And that's what these numbers are here, right? The first number is an x, x1, and this is the y, y1. Remember, we said it goes to the point x1, y1. Here's the point it goes through. So this is x1. So that's going to go right here. But notice it's minus that point. So it's actually going to be minus 2. And over here, we have to minus y1. Well, y1 is minus 5. So it's y take away minus 5. Take away minus 5, that's the same as plus 5. So one thing people often remember this, or the way that people remember this, is it's kind of the opposite of what you'd expect. Even though our point is 2, negative 5, when you throw it in the equation, you end up with negative 2 and positive 5. And the reason for that is because those minus signs right there. Let me do one more example. So I'm kind of squishing in here. Let's say a line has a slope of -3, and it goes through the point -4, 1. Okay, so slope point. So we don't have the y-intercept. We got to use slope point form. So the highlighted y, we always write y. I'm going to skip the next one for now so we don't get confused. M, that's just the slope, which is -3. Bracket, highlighted x, I always write. Alright, now I got to put in my x1 and my y1. Here is, the first one is the x1, and the second number is the y1. So I have to do y take away y1. So I have y, now I have to take away 1. Okay, y take away 1. And over here I have to do x take away x1. So that's x take away -4. Oh, x take away -4 is the same as x plus 4. And again, you'll notice how it's kind of opposite. The point was -4, 1. So in our equation, it's +4, -1. Becomes opposite because of those two negative signs. Alright, let's move along here. We're going to graph a line that has this slope and passes through this point. No problem. We've done this kind of thing before. What are you going to graph first, the point or the slope? The point. -8, 6. -8, 6. Right there. Has a slope of -3/4. So let's think of the negative being with the 3. So here's our rise, here's our run. We're going to rise -3. That means down. 1, 2, 3. We're going to run 4. 1, 2, 3, 4. Let's do it again. Rise -3. 1, 2, 3. Run 4. 1, 2, 3, 4. Hey, it goes right through the origin. I'll do it one more time. 1, 2, 3. 1, 2, 3, 4. And I'll draw a nice blue line through there. There it is. And I guess if you want, I could highlight this blue so you know that I'm talking about this question here. Okay, graph is the second one. Graph the equation in point slope form. So this is point slope form right here. So there's two things we have to figure out from this equation. One thing we have to figure out is what's the slope, and the other thing we have to figure out is what's the point it goes through. The slope should be no problem, because remember, the slope is right here, right before the bracket. So the slope is -1/2. No problem. -1/2. The point does give people problems because they know that the x is in the bracket and the y is here. So guess what a lot of people put as their point? They put 1, -4. That's not true. How come? Remember, it's kind of the opposite. If it's x take away something and you get +1, it must be x take away -1. It's the opposite of the positive one. So it should be -1 for the x. And since it's -4 here, it must be +4. How come? Because y take away +4 makes y take away 4, right? Okay, there we go. Now it's just as easy as the last question once we figured that out. The point is -1, 4, -1, 4, and the slope is -1/2. So down 1/2, down 1/2, down 1/2, down 1/2, etc. And I'll draw a nice red line. There it is, and again, if you want, we can highlight this one red to show that it matches the red line. Okay, there you go, graphing point slope form. Okay, so here's one in point slope form. We want to switch it into slope-intercept form. So remember, slope-intercept form is y equals mx plus b. We want the y by itself. You also, okay, so the first thing I guess is you want the y by itself. You can move this 3 over. So you have y equals -2/3 x. Sorry, 2/3 x minus 2. And when the +3 comes over, it becomes -3. Now, does that look like slope-intercept form? Not really. We want y equals mx plus b. Like, this is no good. We have to get rid of this bracket here. So how are we going to do that? We're going to do the distributive property, or I call it mountains. We have to multiply these two things. So you have to be good at multiplying fractions by whole numbers in this section. So let's take a look. We get y equals -2/3 times x. Well, that's just -2/3 x. -2/3 times -2. Well, negative times negative is positive, and 2/3 times 2. So I'm going to write that over here for you. 2/3 times 2. It doesn't mean 2 times 2 and 3 times 2, because remember, this is over 1. So it's 2 times 2 is 4, and 3 times 1 is 3. So you get 4/3 minus 3. Are we finished? Finished? Sadly, no, because we need to combine these two terms, the 4/3 take away 3. Subtracting fractions. Uh-oh, how do we do that? We need a common denominator. Well, right now, if I'm trying to subtract 4/3 take away 3, that's the same as 3 over 1. So, what's our common denominator? 3 and 1? 3. Keep the first one the same. What do you have to multiply 1 by to get 3? You have to multiply it by 3, so do the same on the top here. You end up with 9. 4 take away 9 is -5, and the denominator stays the same. So, our final answer is y equals -2/3 x, and when I subtracted these, I got -5 over 3. Notice I didn't put plus -5 over 3, I just put minus 5 over 3. It's a better way to do it. You could put plus negative, but I invite you not to, and to do it this way. Okay, it's in slope-intercept form now. What's the slope of this? -2/3, right in front of the x. What's the y-intercept? -5/3, or if you want, 0, -5/3. Alright, there you go. We could now graph it. That'd be a nightmare to graph. I won't make you graph things like that. But at least you can put it in slope-intercept form. Next one, we're going to change this one. This is again point-slope form. We're going to put it in standard form. So, with standard form, we need to remember it's like ax plus by equals c. So we have to get the x's and y's on one side and the constant, the number, on the other. Well, again, we're going to have to use the distributive property here. We're going to have to multiply these things. So y minus 1/3 equals 2/5 x, when you multiply that. And then we have to multiply 2/5 times -6. Well, positive times a negative is a negative. And 2/5 times 6, that's the same as 6 over 1. You get 12 on the top, 5 on the bottom. Alright, we've got some fractions. We don't want fractions in standard form. Remember, we want all integers here. So we look at the denominators, which are 3, 5, and 5, and we ask, what's the lowest common denominator of those? 15. And what we're going to do is we're going to multiply everything by 15. Remember why we do that? Because that'll get rid of all the fractions. You should have no fractions after this step, otherwise you've done something wrong. So let's see if it works. 15 times y is 15y. Okay, 15, but you can cancel the 15 and the 3. The 3's gone, and you're left with just 5 up here. So now it's negative. 5 times 1 is 5. Great, no more fraction. Cancel here, 5 and 15. You just have 3 up here. 3 times 2 is 6x, so equals 6x. Cancel here, 15 and 5 leaves you 3 up here. So it's take away, 3 times 12 is 36. Good, no more fractions. You should never have fractions after this step. Now, we need to get the x's and the y's to one side and the numbers to the other. So which should we move over? Do we move the y to the right or the x to the left? We should move the y to the right. How come? Because we want our x's to be positive, and they're already positive. So we'll leave the x over here, but we'll move the 15y's over, and it becomes -15y. On this side, we have -5, but why don't we move this -36 over, and it becomes +36. Great, now we're almost done. I'm just going to write it the other way around. I'll write the 6x minus 15y first equals 36 take away 5 is 31. We're done. That is in standard form. Okay, write the equation of a line with slope 4 that passes through -4, 6. Okay, we're going to write this in all three forms. You're going to love it, eh? Which one would you write first? Definitely point-slope form, because this is a slope and a point, and it's not the y-intercept. So let's do it in point-slope form. So remember, to do point-slope form, we do y take away y1. So that's the y value here that we know. And the y value is 6. So y take away 6 equals m, which is the slope, so 4. And then x take away x1. X take away -4. Oh, x take away -4 is the same as x plus 4. This right here is point-slope form. Alright, let's change it now into slope-intercept form. So to change it to slope-intercept form, we want to get the y by itself. So let's move the -6 over. So we get 4, x plus 4, but then we move the -6 over, it becomes +6. Not quite there yet. We have to multiply and multiply. So we get y equals 4x plus 16 plus 6. Oh, no fraction this time. It's nice. Just have to add this and we'll be done. So you get y equals 4x plus 22. This is slope-intercept form. Okay, now you want to put it in standard form. For standard form, we want the x and the y on the same side and the constant on the other side. Our x is already positive, so let's leave that there. So we get 4x, bring the y over, it becomes minus y, but we want to move the 22 to the other side, it becomes minus 22. This is good, or you can just write it the other way around. 4x take away y equals negative 22. This is beautiful. This is standard form. Great. Next question, almost the same thing, except this time you have to write the equation of a line that passes through these 2 points. What's the difference between this question and this question? In this first question you know the slope, and in this one you don't know the slope. Guess what you're going to do first? You're going to find the slope. So you have to use the slope formula that you haven't used in a little while here, but remember slope, m, equals change in y over change in x. Okay, so change in y. Well, I'll do it this way. I'll go negative 3, take away negative 9, and then since I did this one, take away that one, I have to do 2, take away negative 5. Okay, negative 3 take away negative 9, that becomes positive 9, so that's 6. And 2 take away negative 5, again we're adding here, so 7. There's our slope, 6 over 7. So now it becomes a question just like the last one. We have the slope, and we have, well, we don't have 1 point, we have 2 points. So which one should we use? It doesn't matter. You can actually use both of them. Hey, let's do it twice and show you it doesn't matter. So let's write it, the first one in point slope form, using this first point. So in point slope form, what we do is y take away y1, there's my y1, so y take away negative 3, which is the same as y plus 3, equals m, slope, which is 6 over 7, and then x take away x1, and that's that value right there, so x minus 2. Okay, what if we did point slope form for the second point? Well, it would be y take away negative 9, so that's y plus 9, equals the slope, 6 over 7, and then x take away the x1, which is negative 5, so x take away negative 5, which is x plus 5. Now, at this point, you might be kind of puzzled a little bit, and you might say, well, wait a minute, which one's right? Unfortunately, they're both right. This is the kind of the problem with point slope form. There's not just one unique equation that works for a line. Like if you're finding the slope-intercept form of an equation for a line, this will be the only form of only equation for a particular line. This will be the only standard form equation for that particular line. But you can have more than one. I mean, lots of them, infinite of them, point slope form, because there's infinite number of points on a line. So it's not the most useful thing sometimes. That's why often what we do once we find this point slope form is we switch it into one of the other forms. So let's do that. Let's switch these both into slope-intercept, and you'll see it for both of them. You end up with the same thing. It's a bit surprising, perhaps, but you do. So we're going to change it to slope-intercept. So let's do 2 steps at once here. Let's move the 3 over, but at the same time, let's also multiply the distributive property, the mountains here. So 6 over 7 times x is 6 over 7x. And 6 over 7 times negative 2, well, positive times a negative is negative. And 6 times 2 is 12. 7 times 1, remember it's 2 over 1, is 7. And at the same time, we're moving the plus 3 over, it becomes minus 3. Alright, last step. 6 over 7x stays the same, but we have to do negative 12 over 7, and we have to subtract 3, which is the same as 3 over 1. So get common denominators. Negative 12 over 7 minus, common denominator is 7. What do you multiply the bottom by? 7. Multiply the top by 7, you get 21. Negative 12 take away another 21 is negative 33 over 7. So this is our answer. This is slope-intercept form. Okay, let's see if we get the same answer when we do this one. So we're going to do the 2 steps at once again. Y equals, we're going to move the 9 over, but first let's do the distributive property. 6, 7x plus 6 times 5 is 30 over 7, because 7 times 1. Move the plus 9 over, it becomes negative 9. Alright, so y equals 6 over 7x. Now we have to do 30 over 7. Take away 9, which is the same as 9 over 1. So 30 over 7. Take away, multiply this by 7, multiply the top by 7, you get 63. 30 take away 63 is negative 33. What do you know? We got Exactly the same answer. 6/7 x minus 33/7, 6/7 x minus 33/7. So it works. It's great. Even though point slope forms could be different, once you switch them to slope intercept, it'll be the same. Should we switch them into standard? I know you're saying no, but let's do it. So since I have denominators here, I have to multiply by the common denominator. Obviously, the lowest common denominator is 7. So when I multiply y by 7, I get 7y. When I multiply this by 7, the 7's cancel, so I'm left with 6x. When I multiply this by 7, the 7's cancel, I'm left with 33. Almost done. All I need to do is move the 7y over, so I get 6x minus 7y, and move the negative 33 over, so positive 33 here. I'll rewrite it. 6x minus 7y equals 33. Of course, it'd be exactly the same here. I'm not going to do it again because it's exactly the same thing. And this is standard form. All right, we're done. Lots of work, isn't it? Okay, last question. We're going to write, now this time we're going to do the same sort of thing, write all three forms, but this time we have the line, and we have to write it in slope-intercept form, standard form, and point slope form. Okay, let's start with slope-intercept form. So there's two things we obviously need. We need the slope, and we need the y-intercept. So slope-intercept form is y equals m. That means we need the slope. Well, let's pick some points. Here's a pretty point, and here's a pretty point, and there's actually another pretty point right there. So I'll just pick the first two. So here's my triangle. 1, 2, 3, 4, 5. 1, 2. So the slope is 5 over 2. But wait a minute, is it positive or negative? Negative. So it's negative 5 over 2 x. Now, the y-intercept. What's the y-intercept? It's negative 1. So don't put plus negative 1, just put take away 1. There you go. That's slope-intercept. Slope-intercept. It's so fast. I just love slope-intercept. Okay, standard form. Well, to get standard form, probably what you do is you take slope-intercept form and just switch it. So in order to switch it, we want to get rid of the fraction. So the only denominator we have is 2. We have to multiply everything by 2. Multiply y by 2, I get 2y. Multiply this fraction by 2. The 2's will cancel, so you'll have negative 5x. And don't forget, you'll also have to multiply this by 2, so you get minus 2. Okay, we're almost done. In fact, the only thing we have to do is we have to get the x's and the y's on the same side, and we want our x's to be positive. So why don't we move this negative 5x over, and we'll be gold. Negative 5x becomes over and becomes 5x. The 2y stays over there, and the negative 2 is over here. We're finished. Okay, point slope form. Now, for point slope form, there's three different ones based on what we can see of this line. There's three different point slope form that will work based on whether we use this point up here, this point here, or this point here. Let's do them all. I love it. This point here is negative 2, 1, 2, 3, negative 2, 4. So if you use negative 2, 4, then slope point form would be y minus the y value, so y minus 4, equals m, that's the slope. Well, we already found the slope was negative 5 over 2. And then you would do x, take away the x value here. X take away negative 2, that's x plus 2. Okay, so that's one form. What if you use this point? What if you use 0, negative 1? Well, we do y, take away the y value, so y take away negative 1 is y plus 1, equals the slope, negative 5 over 2, and then x, take away the x value, so x take away 0. And that would be it. Okay? What if you use this point, which is 2, 1, 2, 3, 4, 5, 6, 2, negative 6. If you use 2, negative 6, then it would be y, take away the y value, so that's take away negative 6, or y plus 6, equals the slope, negative 5 over 2, and then x, take away the x value, so x minus 2. So if I asked you to put this in, I gave you this line and said, write the point slope form equation, you could put any one of these three equations, and I'd have to mark it right. Should we switch them all into slope-intercept form and show that they're all the same? I actually really want to, because I just think it's so fun. So you can stop the video now if you want, but I'm going to do it. What you do is you do, for example, the distributive property here, negative 5 over 2x, and negative 10 over 2, because negative 5 times 2 is 10, and 2 times 1 is 2. Bring the negative 4 over, you get plus 4, and then you get y equals negative 5 over 2x. 10 over 2 is 5, so negative 5 plus 4 is negative 1. Did we get the same thing as the highlighted? We did. We got exactly the same thing. And you'll get the same thing here and here too. The second one's so fast, maybe we should do that one too. Y equals negative 5 over 2x. Negative 5 over 2 times 0 is just 0, so it doesn't make any difference. And then move the plus 1 over, it becomes negative 1. We got the same thing again. Let's do it one more time. Y equals negative 5 over 2x. Negative 5 times negative 2 is positive 10 over 2. And then move the positive 6 over, it becomes negative 6. Okay, y equals negative 5 over 2x. 10 over 2 is 5, take away 6 is negative 1. You get the same thing again. So it doesn't matter which point slope form equation you get, they're all correct. And if you switch them into slope-intercept form, which you usually do, you get the same answer every time. Okay, that's a lot of work today. I know that's probably a little bit overwhelming, but it is important stuff, so try to learn it. Come see me if you need help. All in the sun, having fun, it's in my blood.